Hey there, I'm Sean MacArthur, author of Hyper, and I'm here to talk a bit about why we got Hyper in HTTP library as a backend in curl, and what does that even mean, but you should see. So let's get going. First of all, we're going to talk about why did we even bother putting Hyper in curl in the first place. Then I'm going to spend some time on how we did it, if it helped at all, it did, and who did it, and then lastly, what you can do. So, first of all, the why. And the why is for a safer, memory-safer internet. And that's because, if we back up some, as you've been hearing, curl is everywhere. There's over 10 billion installations. Humans interact with it. Used to just use the internet with just a PC a few years ago. Now, besides that, we've got a phone in our pockets, maybe we've got a watch, got pacemakers, you got things in your shoe, all sorts of things. They're all talking to the internet. And they're probably using curl to do it. So, curl is everywhere. But curl is C, as Daniel likes to point out. And C, written by humans. Humans, even the best of humans, write bugs. And they write, in C, memory safety bugs. Or as Daniel knows, that 50% of the curl's vulnerabilities, security vulnerabilities over the lifetime of curl, have been what we call C mistakes. And that is buffer overrides, overreads, null pointer, things like that. So it's used everywhere, but with these memory vulnerability, these memory safety problems, there's cause for concern, you could say. So that's where Hyper comes in. Hyper, well, that's also a website. You can go to https hyper.rs and learn about what Hyper is. Hyper is an HTTP library. We've got a server, we've got a client. Supports HTTP 1 and 2, 3 is on the way. Supports non-blocking I/O, which is what curl's underlying interface likes as well. It's super fast, it's correct, robust. We use it in a lot of places. Handles edge cases, very tested. It's been developed for 7 or 8 years, so it's not brand new. We made sure that it's been seen a bunch of different kinds of HTTP in the world, HTTP that's not quite HTTP and all that kind of flavor. And many people use Hyper. Many people trust Hyper for their HTTP needs. AWS, Buoyant, all these different companies. But particularly interesting about Hyper is that it's written in Rust. And why is it written in Rust? First of all, that's part of what makes it be able to be so fast. It's as fast as C or C++, but it's memory safe. And I'll talk about that in a moment. But many times, talking to people, myself included, Rust has this principle of, I came here for the speed, but I stayed for the type system. And that's because this type system is just so expressive. You can freely encode more logic into the types. The types don't cost any more at runtime. There's no implicit boxing. There's no additional cost. There's no indirect calls. So you have new types, you have some types, and this allows you to, at compile time, check for bugs, as opposed to at runtime, hope that you didn't write any. And that's on top of it being memory safe. When I first got into Rust, I wanted to write some web server stuff, and, well, there was a TCP stack, but that was it. So you needed an HTTP library, and that's where I started working on Hyper. But let's talk a little bit more about that memory safe part. You can go to memorysafety.org and learn a bit more, especially if you click on this excellent write-up up at the top. There's what is memory safety, and you'll get to learn what exactly it means, what kinds of problems can occur, and very importantly, what kind of real damage it can do. It's not just this academic, oh, things should be safer, but memory safety vulnerabilities in the past have caused significant damage to mankind. So it's worth taking a look at. It's very well written. So in recap, why are we doing this? A memory-safe internet. That's the goal. Make our internet access safer from a memory point of view. Now, let's talk a bit about how we got Hyper actually into curl. What did we even do? And we worked at it from a couple of angles. First of all, Hyper is in Rust. We had to make a C API for Hyper. So to start, we did the client side. Curl didn't need a server API, so we worked on the client side. And while it's currently unstable because we're making sure that curl's use of it works, once that's stable, we can make it provide the normal Semver API compatibility that it normally does. It's modeled with a bring your own IO format. This is the way it works in Rust as well, but what this means is that Hyper doesn't care what the IO thing is. It could be TCP, UDS, pipes, a memory buffer, a quick stream. Like it doesn't matter. All it needs to know is how to read and how to write. So this fits into curl because curl likewise allows people to provide their own sockets, their own read and write things. So that works pretty well and runs HTTP over it. And this also models Rust's concept of futures. It's async await design. Non-blocking IO uses futures, and what that ends up meaning, it does as much progress as it can, writing as much to socket, reading as much as possible, until you get an E again or no progress, and then you register with some sort of polling thing, which you register with. That is also not something that Hyper really cares about. That's not what futures care about. We allow the caller to figure out, okay, hey, we couldn't make progress, register however you like. Again, this turns out that it works out very similarly to the way curl's multi-interface works. So we had to make this C API on Hyper side. On curl side, there was the integration that Daniel did. So curl had this concept of different backends for many parts, kind of like VTLS. And this time, Daniel worked on making HTTP a backend, where it could be the C backend that curl has had all along, but now it can fit in others like Hyper. Good news is that Hyper's handling of HTTP pretty much just kind of worked. It didn't really need to be changed much, which was great news for Hyper. It means that, like I was saying, it's battle tested and works in most cases. There were two changes we had to make. It's not because it was wrong, but because curl understandably didn't want to have behavioral changes. Now, they didn't make HTTP different, but curl is very interested in it not even being aesthetically different. So I'll talk about that in a slide or two, though. Daniel also updated the test driver, adding a hyper mode. And this is interesting. It's because the way Hyper works, it parses the headers into some strings, and we give those strings back to curl. Well, curl, when it then passes it on to users, it likes to pass the whole line. Hyper chops off the line endings and just gives the strings, fixed size strings. So curl fabricates the line ending to then give it to the user. Since it has to fabricate the line ending, it doesn't know what the original line ending was, it fabricates a CRLF. But the tests are written just to have an LF. So hyper mode just basically makes it so that we don't care about that difference. And of course, C API being designed by a Rust programmer, at times it did things that were less C-like. So Daniel was kind and helped to point out, this doesn't make sense. This is not the way we would do it normally in C. And we worked on that. Eventually, I feel we got to a design that feels kind of pretty similar to curl's multi-interface. Daniel may disagree, but that's just my point of view. When I take a look at the docs and see how I can use the curl multi-interface, it feels very similar to the way Hyper's lower level client works. And currently it works, quotation marks. Everything works. even now, you could go and build it yourself and use curl with hyper as its backend, and the vast majority of features and behavior works you expect. Let's talk a little bit about what has happened since the last time we talked about this. We did a webinar talking about all getting hyper into curl a bit over a year ago. I listed a few things that didn't work so well. So since then, what's gotten better? First of all, we've gotten the C API, now the documentation rendered on a web page. That's at docs.rs/hyper, the FFI module. You know, there's got pages for all the types and the functions, some documentation about how that works. As always, docs could always be better, but that is a significant improvement over just reading through a header file. We also fixed significant annoyances that existed around producing a C.lib. And that's what what Rust calls making a dynamic library that uses the C API. Before Hyper's manifest file, the cargo.toml, you'd have to say, hey, always build a Rust lib and a C.lib. There was no way to turn it off. And that was wasteful. If Rust users were compiling Hyper, they'd compile both. Curl was compiling both. This was unfortunate because both sides, they didn't need the other one. And it also caused some issues around cross-compilation, because sometimes Rust users were compiling to other platforms not on their computer, Android, iOS, or whatever, and trying to generate the C library caused some issues. So we proposed a Rust RFC adding a command line argument to cargo, and you can see it there. We added the argument crate type. So now we were able to remove the crate type from the manifest. And now when you build Hyper itself, you can say, hey, the default is a Rust library because most people are using Hyper in Rust. But you can say, actually, I want a C.lib now instead. And you'll only build one or the other, or whichever one you specify. So that's a big win. Now, let's talk a little bit about the symbiosis of us getting this together. And what do I even mean by that? Was it a symbiotic relationship? What I mean is, even if we didn't stabilize all this work, both projects have benefited. If we were to be like, you know what, don't need this, we're out of here, let's just part ways, both libraries have gotten better from the process. Let me talk a little bit about that. So, Hyper got better. And Hyper's Rust API, it takes advantage of deprecations and the spec-related details that allows us to make some optimizations. And we can skip needing to store a string for the reason freeze because it's deprecated. HTTP2, HTTP3 don't even use it, and the spec recommends you shouldn't be relying on this. So we don't even save a string for it. We save some words, we save some allocations, or header names. The spec points out that header name casing doesn't matter. HTTP2, HTTP3 force names to be lowercase. So in Hyper, what we've done normally is just everything is always lowercase, which means that when we're ever indexing, comparing, inserting, etc., we no longer have to do a case-insensitive match and case-insensitive hashing. We can just do the faster matching and hashing on a lowercase value. But curl wanted that behavior disabled. And mostly because while those things don't change, are not supposed to change the meaning of anything, curl doesn't want any aesthetic changes as much as possible. Which means that it's willing to opt into, I want those extra things, even though in Rust most people don't. What that did mean though, and huge thanks to Liam Warfield for helping us figure that out too. Also, same thing with the field order. The order is not supposed to matter. At least the names are not supposed to matter. The order that you get the values, if you have multiple values for the same name, yes, that matters. Hyper keeps care of that. But the names are not supposed to matter. Liam helped us out in getting that together. But by doing this to be exposed in the C API, we had to add it inside Hyper's internals. And then we made it an option, hey, anyone that does want this in Rust, you can turn it on. And now they can have it. And there are some users that are very much benefiting from this, especially proxies, gateways. You know, they want to ship things exactly as they saw them, so they opt in to accessing these things. Curl also got better. There was some fixing to handle the way responses when they had a transfer encoding, but it didn't say chunked, it said something else. Curl used to assume that that meant, well, then if it's got a content length, we handle that, but the spec was clear not to do it that way. It's important that we follow the spec in these instances, because not doing that leads to the ability of message smuggling, and it's especially a problem if you start to plug together servers and clients making proxies. If you have them disagreeing on the length of a response or a request, then you can smuggle messages in between. So curl fixed this even if you aren't using Hyper. Awesome. Daniel also updated the C HTTP backend when integrating Hyper and found out that Hyper rejects headers that have null bytes in them. He updated the C HTTP backend, and he noted in the PR to do that it protects curl from any header string that has null in it. So that way, if you were ever to take that string and pass it into a normal C string thing, it wouldn't accidentally think this was a null terminated string. So that helped out too. Now, how far along are we? Well, we're 98% of the way there. 98% or so of the tests are there. We just have the last 98% to go. You know, we're like the loading bars right there at the end, and well, taking far longer than the first 98%, of course, because that's just how anything in life works. So, to get the last few tests to work, you know, there's 800 something tests to go. Most of them, 98% of them are done. I wrote up a guide on SeanMonster.com. You can go and if you search for this phrase, help stabilize Hyper and curl, you'll find it. Helps instructions on how to set up your environment, how to build curl so that it uses Hyper, and then how to select a test and debug it. How to enable logs, and then ideally you could do this yourself and then file a bug report explaining why this test doesn't work. We know some of the tests don't work, but why? That I don't know. So this guide helps, and then I've also set up a project board, kind of Kanban style. You can type in this URL here, and it'll show all of the tests that are currently disabled, the state that they're in. We have no idea why they're not working. We have some idea. We need a fix, and it's done. So these two things are helping us to get through that long tail of contributions. And I have here a list of awesome people who have used that or helped in other ways. These are people that have helped us to get through the long tail of final tests. And these are people that have built a personal copy, plugged it into Git, for instance, or what have you, and then reported bugs. They've used the guide that I talked about, found the root cause, reported what's going on, which allowed someone else to fix it. They updated Hyper to fix one of those bugs, or any of the others. Or they updated curl to fix one of those tests. So, lots of love for all that are here. And if I missed anyone's name, oh, I'd feel horrible. But hopefully you understand. So, now what can you do? And I mean you, the people that are watching. You know, the expression, don't try this at home, kids. You definitely can try this at home. You can, right now, go to curl, build Hyper, build curl, use it yourself, and make that your personal daily curl driver. That will help finding bugs. That will help making sure, like, yes, everything is it was working well. If there are bugs that are found and there's no tests that test that behavior, then perhaps we should add some tests. Secondly, you could go to the guide and look at the Kanban board and help debug and patch some of the last few tests. There's only a few to go. 10 or so, 15 maybe. You could also, if you're a company or you hire some engineers or you like to fund people in open source, you could fund someone else to do this, especially when you think about what impact it has. Third, if you maintain the curl package in some distro, you can start to plan how to enable building curl with Hyper once it's ready to go. Or maybe you even provide an unstable version, experimental, what have you. Using it is a huge, huge help. And then, of course, telling us if it works and if it doesn't work. So, come join us. Hyper.rs, that's the website. Source code's on GitHub. We'd love to have you. Thanks so much for listening.